Hello everyone. I, Nilima Warade, working as an assistant professor in the Department of Electronics and Telecommunication Engineering from All India Sri Shivaji Memorial Society's Institute of Information Technology, Pune. Today, I will be discussing on basic design steps of state machine. Steps for design of state machines are state diagram, state table, transition table, and state reduction. To understand the state machine, or precisely saying the finite state machine, one must understand different design steps of it, which are as mentioned in this slide. So let's start with one by one design steps. First design step is to draw a state diagram. This is also called as a state graph, which looks like as shown in this PPT. A state diagram describes the behavior of a single object in response to a series of events in a system. That is, it represents the relationship between the inputs, present state, next state, and the output of a sequential circuit. A circle is used to represent the state in the state diagram, and the transition between the states is represented by the directed lines connecting to the circles. Whether the transition is taking place in the same state or moving to other state is shown in this figure. The binary numbers or the characters inside the circle indicates the state represented. The directed lines sometimes labeled with two binary numbers. These are generated by either a symbol or a state, are either a Mully machine or a Moore machine. And when the output is represented in a state itself or in a circle, then that is a Moore machine or a Moore circuit. Moving further, with respect to the state, we can now write the state table, or we can just draw a state diagram. It is nothing but a tabular representation of the state diagram, as you can see this on this particular slide. It shows the relationship that exists among the inputs, outputs, present states, and next state. For example, when present state is A and when the input is 0, the next state would be A, and when the input is 1, the next state would be C, and that time the output is 0, which is actually shown in this particular state table. Moving further, there is the next basic element is a transition table, or sometimes it is called as statement assignment. It refers to using state variables to define specific states and how the values of the state variables are determined, or the method of assigning binary values to the states of a sequential circuit is called as the state assignments. For example, as shown in this slide, sometimes it may happen that your states 0, 1, 1, 0 or 1, 1 may reach to a 0, 0 state after certain input. Then you can show this particular state in this transition table as shown in this particular slide. Next is the state reduction. Basically, it means to eliminate the redundant state. By doing the state reduction, one can reduce the number of flip-flops and logic gates and ultimately reduces the overall cost of this particular circuit. For example, if two states are found to be equivalent, we can remove one of them without affecting the input-output relationship. This state reduction can be done either by determining the state table for the given state diagram or by finding the equivalent or the redundant states. This all are the different basic design steps to design any state machines or any finite state machines. This is all for today's video. Thank you everyone.